So in this video we're going to have a look at some problems using the index laws. The first question says 2p times 3p squared times 4q. Now all of these are being multiplied together, so we're going to break it down into the numbers which we can multiply, then the like terms, and then any other terms that are there. So for the first one, we've got 2 times 3 times 4. So we can multiply all three numbers. 2 times 3 is 6, times 4 is 24. That goes first. We then have to apply the index laws and we can collect our like terms. So we've got a p on its own, which is really p to the power of 1 times a p squared. So if it's a times, we're going to add our powers. We have a power of 1. Add the power of 2, which gets us a power of 3. So we have p cubed, or p to the power of 3. And then this q can't be combined on its own, but we don't need to write the multiplication sign there, so we can just write it as a 24p cubed q. Okay, we don't need the times signs. Moving on to part B then, we've got 12x cubed y squared over 3xy. So again, let's break it into the separate parts, and we'll deal with the numbers first. We have 12 divided by 3, or 12 over 3, which gets us 4. We then have an x cubed divided by an x. So if it's over, it's still a division. The x on the denominator has a power of 1, so we have 3 minus the 1, because it's a division, which gets us an x squared. And then with our y's, again in the denominator we have a y to the power of 1. So we have a power of 2 divided by the power of 1. So it's a subtraction there. So 2 minus 1 gets us 1. So we could write that as y to the power of 1, but we don't need to. We can just write that as a y. So we end up with 4x squared y. Moving on to 2c then. Now, there's a few different ways that we can deal with this, and I'll show you the alternatives. In a later video, we'll look at the connection more to do with this. Now, if we break it into the separate parts again, we have a 6 divided by a 12, which gets us a half. Then, if we're using our powers, we have x to the power of 1 divided by x to the power of 2. So it's a division, so we subtract the powers. 1 minus 2 is minus 1, so we get an x to the minus 1. And then for our y's, we have a y cubed over y, so we have a power of 3, and then divided by y to the power of 1. So we subtract the powers. 3 minus 1 is 2, so we have y squared. Now alternatively, we can write this as a single fraction. Now, because the 2 would be in the denominator here, we can write the 2. The y squared, we can write up in the numerator. But really, if we're cancelling the x's here, there's 1x left in the denominator, so we can write the x in the denominator. So these are actually alternative forms. They're both correct. This is as a fraction, this is in index notation. And in a later video, we'll look more at the connection between those two forms. Moving on to 2d then, we have an x cubed all squared over an x squared all cubed. So for this one, we've got our brackets. So if we have our brackets, what do we do with the indices? We multiply them. So in the numerator, we have x, 3 times 2 is 6. In the denominator, we have x to the power of 2 times 3, which is also 6. And if we've got x to the 6 divided by x to the 6, well, it's something divided by itself, which simplifies to 1. Alternatively, you could write it like this and say, right, it's a division, so we subtract the powers. So 6 divided by 6 is 6 minus the 6, because it's a division, gets us 0, and anything to the power of 0 just gets us 1. Moving on to the questions in 3 then. So 3a, we've got 2x times 3x minus 5 in the brackets. Now with our bracket expansion, we multiply the term on the outside with each of the terms in the brackets. So first of all, we have 2x times 3x. Now it's important because you've got to remember with the expansion it is a multiplication. So our index laws are going to apply the same as they would if we were to multiply, like in 2. So we have 2 times the 3, which gets us 6. Then we have our x. We have an x to the power of 1 here, times an x to the power of 1 here. So 1 plus the 1 gets us a power of 2. And then slightly simpler with the next term. We've got 2x times minus 5, make sure you take the sign into account, which gets us minus 10x. Moving on to b, slightly more complicated, but it's the same process again. The terms on the outside, so this t squared, is going to multiply each of the terms inside the bracket. So we have a t squared times 3t cubed. So we've in effect got 1 times 3, which is 3. Because it's a multiplication, for our powers, we are going to add them. So we've got 2 plus the 3, which gets us a power of 5. And then we're going to multiply the t squared with the second term. So we've got t squared times minus 5t. So taking the sign into account, we have a minus. We've got 1 times 5, which is 5. And then for our t, we've got a power of 2 there, a power of 1 there. 2 plus 1 gets us a power of 3. Moving on to c then. So we've got an x on the outside, and we're going to multiply each of the terms on the inside. So we've just got 3 terms this time. We've got x times x squared, power of 1 plus the power of 2 there gets us a power of 3. We have x times plus 3x. We end up with a plus. 1 times 3 is 3. Power of 1, add them together, gets us a power of 2. And then finally, x times minus 5x to the 4. Take the minus into account. 1 times 5 is 5. Power of 1, power of 4, add those together, gets us a power of 5. Then we have d. 2 sets of brackets this time, but we follow the same idea and we expand. 2x times 7x. 2 times 7 is 14. X to the power of 1 plus the power of 1 there gets us an x squared there. 2x times minus 4. Take the minus into account. 2 times 4 is 8. We've got our x from the first term. Then we do the second bracket expansion. Minus 2 times 3x is minus 6x. Minus 2 times minus 5. The minus times the minus becomes a plus. That's very important. And the 2 times 5 gets us 10. Now we could leave it like this, but actually we can simplify this. So we can collect our like terms together. So we've got minus 8x minus 6x, which gets us 14x squared minus 14x plus 10. So that's our final answer for 3D. Moving on to 4A then. So this one, slightly different. We just want to simplify the expression. Now, if you're dividing by the term x to the 4, what we can actually do is we can split this into 2 separate fractions and deal with them individually. Because all of this is being divided by x to the 4. So we can really say we have x to the 8 divided by x to the 4 plus x to the 4 divided by x to the 4. So all we've done is we've just separated those into 2 separate fractions. Once we've done that, then we can apply our index laws. So we've got x to the 8 divided by x to the 4. 8 minus 4 gets us a power of 4. X to the 4 divided by x to the 4, well, we looked at a similar case to this. It's going to get us 1, or alternatively you get x to the 0, which simplifies to 1, so we get plus 1. Moving on to b then. we've got 6x to the 5 minus 5x to the 4 over 3x cubed. We're going to do a similar idea, split it into two fractions. So we have 6x to the 5 over 3x cubed minus 5x to the 4 over 3x cubed. So when we simplify this, 6 divided by 3 gets us 2. X to the 5 divided by x cubed. Because division, we subtract the powers. 5 minus 3 is 2. For our numbers for the next one, well, we can't simplify the fraction 5 over 3, so we're going to leave that as minus 5 over 3, but we can simplify the x's. X to the 4 divided by x cubed. Because the division, we subtract the powers. 4 minus 3 gets us 1, so we can just write that as an x there. Moving on to the last one then, we've got 18x to the 9 plus 24x to the 4 over 6x to the 4. Just like the last two, we can separate this into two separate fractions. So we can write this as 18x to the 9 over 6x to the 4 plus 24x to the 4 over 6x to the 4. We then simplify each of these fractions. So 18 divided by 6 gets us 3. X to the 9 divided by x to the 4. Because division, you need to subtract the powers. So 9 minus 4 gets us 5. For the next fraction then, we've got 24 divided by 6, which is 4. So we've got plus 4. X to the 4 divided by x to the 4, which simplifies to x to the 0 or just 1. So in effect, we've got 4 times 1. So we don't need to write that. We can write 3x to the 5 plus 4, and that would be our final answer.